Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine you are standing on the peak of Mount Everest, and your friend is standing at sea level. You are only a few miles apart, but according to the laws of physics, the rate at which time passes for you is fundamentally different from the rate at which time passes for them. This isn't science fiction, it is the absolute measured reality of general relativity. The initial paradox we need to address is the misconception that high gravity speeds up time. In fact, the opposite is true. The stronger the gravitational field, the slower time runs. This fundamental truth is key to understanding what we call the chronometric paradox, the measurement of time differences across incredibly small gravitational gradients. At the core of this phenomenon is Einstein's revolutionary idea that gravity is not a force, but a curvature of the four-dimensional fabric of spacetime. A massive object, like Earth, acts like a bowling ball dropped onto a trampoline, creating a deep well. If you are closer to that well, at sea level, the spacetime around you is more intensely curved, and therefore, time must move slower. If you are higher up, on Everest, the curvature is less intense, and your clock ticks slightly faster. The difference is minuscule. We're talking about nanoseconds. But in modern physics, precision is everything. Scientists have used ultra-precise atomic clocks to measure time dilation over differences as small as 1 foot. In one famous experiment, researchers placed two identical atomic clocks, one on a basement floor and one on a lab bench just 33 centimeters higher. The clock on the bench, being slightly further from the center of Earth's gravitational pull, was found to tick marginally faster. This small discrepancy has massive real-world implications, particularly for the Global Positioning System, or GPS. GPS satellites orbit Earth at about 12,000 miles up, experiencing two types of time distortion simultaneously. First, due to their altitude, the gravitational effect is weaker, making their clocks run faster than clocks on Earth. Second, due to their speed, special relativity dictates their clocks should run slower. The net effect is that without constant correction, the satellite's clocks would gain approximately 38 microseconds per day. If GPS systems didn't account for this chronometric paradox, navigational errors would accumulate at a rate of several miles per day, making the system useless. We call this the Clockwork Singularity, because, at the extremes of gravitational influence, the effect becomes non-linear and approaches infinity. The ultimate demonstration of this time warp is the black hole. As matter collapses into a singularity, the spacetime curvature becomes infinite. If you were observing an astronaut falling toward the event horizon of a black hole, you would see their clock slow down drastically. Their motions would become sluggish, their light increasingly redshifted, until they would appear to freeze entirely just outside the event horizon, never seeming to cross the boundary from your distant perspective. For the astronaut, however, time continues normally until the moment of spaghettification and eventual collapse. This gravitational dance of time reveals that time is not a steadfast, universal measure. It is fluid, relative, and inextricably linked to space. It means that everyone on Earth is technically aging at slightly different rates depending on their location, altitude, and even velocity. While the difference is too small to perceive in a human lifespan, it forces us to rethink the universe as an interlocked, dynamic system where mass dictates the rhythm of existence itself. Every time you use GPS or consider the vast expanse of the cosmos, remember that time is bending and stretching around you, accelerating or decelerating depending on how deep you are in the gravitational well. The clockwork of the universe is far more intricate and sensitive than we could have ever imagined. For more incredible facts like this, don't forget to subscribe and turn on notifications.